Very good evening, friends. Welcome back to the session. So good to see you all again. So today we are going to understand one of the machine learning algorithm, that is a classification model, which is helping us to understand the prediction of booking. So I would like to recall what we have discussed in the previous sessions. So the first, we try to understand the application of machine learning and artificial intelligence with respect to the data analytics, that is hospitality analytics. And then we try to understand what are the different steps that we followed for project management methodology, that is CRISP MLQ, where we follow till deployment and maintenance of the project. And as a part of CRISP MLQ, we do require dealing with data, which we refer to be as exploratory data analysis, which is a heart of any data science project, that we need to perform the data analysis before getting into the model. So this also contains of data pre-processing. And after this, after knowing all these basic fundamentals of data science before getting into the actual topic, how the model works on the data. So we just need to be mentally prepared for the data and be ready with the data. After the data pre-processing, we select the models. We select the machine learning appropriate models, whether it can be regression models or classification model or unsupervised. These are all supervised learning model. And we have unsupervised learning model, that is clustering model. So in the previous session, we have discussed unsupervised learning model, that is k-means clustering model. So where we have made a cluster and then we try to understand the strategy. Now, we'll just move on to one of the next method, that is classification model. So we'll try to take a classification model and then we'll try to understand how it works. So under classification model, we have decision tree, random forest, SVM, and KNN. So we have these many classification model, but we try to consider KNN and decision tree as of now for the particular data analytics. And we'll try to understand how these two importantly working, because when we understand KNN, it is almost similar understanding support vector machine. When we understand decision tree, it is almost understanding a part of random forest. So hence, these two classification model has been considered for the data analytics. So now, first, I would like to take a simple classification model, that is KNN. So next, I would like to take in tomorrow's session, that is regression model. And then we have a classification model. What we are taking is decision tree. And then we'll move on to artificial neural network. So how does this also supports? So we have taken clustering model, classification model, regression model, and AI also. So we covered most of the machine learning algorithm as well as deep learning concepts, which is helping hospitality analytics. And also we'll see some of the challenges at the end of the day, where you can also give your contribution in understanding, doing research work on the particular area, where you can proceed further in making these models more accurate when compared to the existing one. What we are understanding with the data that what we have is particularly we are getting almost 90 to 95% with all the models. So you can just make use of other regularization technique, transformation technique, standardization, normalization technique, boosting methods. So all these can be improvised to make accuracy, make your model more accurate. Okay, so you can just go towards that as an advanced one, and then can understand in depth of the data science. So the session will start with the understanding of unsupervised supervised learning model, that is classification model, what we referred as KNN. Okay, so we'll try to understand the model and then proceed with the hands-on. So we need to understand what is K nearest neighbor classification model. So why we refer that as a classification model? So under supervised learning model, so we have regression model and classification model. So when you know the output, yesterday when we were discussing about unsupervised learning model, the output we doesn't know. We were not knowing what is the output from the given data. We just do some simulation, calculations, and then try to understand what the data is talking all about, what the data is telling all about. From the output, what we are getting. Let's say example, few datas we have taken, that is lead time and ADR. And based on that, we have taken a market segment. Okay, so we had 5 market segments. All these based on lead time and ADR, we have to segregate that to a different market segment. So some of the market segments like online, offline, corporate, groups, direct. So these are all contributing towards the some of the important valuable customers. Let's say example, few people who booked from online are valuable. How do you say? Few people booked from offline, they are also contributing something. They are also important customer. How do you say? So the main task is to identify who is the efficient or effective or the customers that are very much required, since they are booking from various ways of booking, but still we just need to understand how many of them are booking offline, how many of them are booking online, together how many of their booking. So all these understandings can be done with the help of k-means clustering. So we have seen without knowing any output. But here today, we just need to understand the data and we already know the output. We already know the output. How do you say that we already know the output? Okay, so I'll tell you. When you already know the output, if you have continuous value, what do you say continuous value? When I say continuous value, the value keeps on changing for every parameters, for every change of value. So value keeps on changing. So for 1, 2, 3, 4, 5, 6. So it keeps on changing. The value keeps on changing. The value keeps on changing. When you are changing these values, it is not constantly changing. The value keeps on changing means constantly. It is not constantly. If it is constantly changing, we say that the data has a strong linearity. Okay, strong linearity. Either it can be a positive or negative. When it does not have it does not have any constant variation, irregular variation, then also we need to identify what is the relation between these x and y parameters. So when there is a change of the value, we just need to identify how strongly it is related with changing the values. And then we need to understand whether it is strongly correlated or moderately correlated or less correlated. In the sense, it needs to be dependence. When I increase the value of x, the y value should also increase. So that we call it as positive correlation. So regression tells about two parameters or more than two parameters, which is helping us to understand how they are related each other. So only when you consider the values that is keeps on changing, we just need to understand how they are going to depend each other. So for regression analysis, you do require some of the continuous values. Now, when you have continuous values, when you have one feature, and you have more than two features. So when you have only one feature, let's say example, X is a feature and Y is a output feature. This is input feature and this is output feature. So here you have X1, X2, X3 and so on till Xn. These are the input features and these are the output feature. Output feature is only one. So how the variation of X1, X2, X3, X till Xn will impact Y. So which we refer to be as multiple linear regression. When it comes to this input and output with one feature, we call it a simple linear regression. Now this is all about regression. Now it is done. Now we just need to concentrate mainly on classification. When I say classification, you will be having some categories. You'll be having some categories. The problems like the email is spam or not spam. Whether the disorder exists or not exist. Whether he has passed or failed in the exam. Whether the people stayed the whole night or not stayed. Whether they booked or not booked, cancelled. Whether the particular booking is done in the month of Jan or Feb or so on till December. So in which month it has been booked mostly. So like this, you will be having categories where you can understand with the help of this, we can make your strategies. So these strategies will help you to improve the revenue profit of the industry, of the hospitality industry. So the KNN supports in classifying, understanding to which category it belongs to. So we already know from the data. So how many bookings will be there? How many categories, market segments will be booked in the month? So we have taken the month that has been booked, okay, and also market segment. So which market segment is coming and booking there in which month? Jan to December. So we just need to understand from this by doing some calculation. Let's say example, Jan, we have 2 bookings, and Feb, we have 3 bookings. So these are all some of the similarities, their bookings. So these bookings of the market segments, they belongs to Jan. That is a similarity. So here we just need to identify between the data points. Let's say example, we have this. Let's say example, I have these as a value. Consider this. So you can directly say that these 2 categories, whatever you are seeing, has some features. You can see that. Not just because I've written, it is circled. It can be anything, but it has some features. What is the features? It has the less X value and some Y value. With the same Y value, when you increase the X value, you will get another classification. So when you increase X value, what happens to the Y value? So it almost remains constant, but it has some variation with respect to X. So when I say, let me give you an example that some people will book their hotel or travel in the month of Jan. Some people will travel in Feb. So like this, different people will travel for the same place. For the same place and same hotel, they have blocked in variety of, in different month, December, and these bookings are also done by different market segments. Those segments we have told already, that is online, offline, groups, direct, corporate. Let's say example, some of the corporate members, they booked in the month of December. They used to book in the month of December. Okay. So there are plenty of similarities, like most of the corporate they'll book in the month of December. So that is helps us to make our strategies. We'll tell hospitality industry that most of the bookings will come in the month of December, where you will be getting profit. So for that, we need to attract the people. Why there is a booking between in December? Because you'll be having December 31st, where that is the end of the year, and you'll be celebrating Jan 1st. So some of them will book, and that is also Christmas time. So you'll be having more bookings. Hence, the hotel industry or hospitality team will make their strategies to improve their profit margin. They also need to concentrate on electricity, water, accommodation, food, employees. So everything they need to maintain, and they set the price for the room. Hence, you can see that based on the seasonal, you'll be having a price issue, price increasing. When you go in the month of June or July, where you doesn't have any occasion, the price will be normal. You don't have much price increased by hotel industry. Whereas in the year, in the month Jan or September, October, November, December, you will be having more profit because more people will be traveling all together, having a journey with their family, relatives, friends, and corporate teams year end. So hence they'll be increasing the price, not that much of increase. So they'll understand 10% of increase or 20% increase. So making this strategy will help to by our machine learning model. So today we are going to understand how far it is going to understand in which month you will be having benefited. So this is going to identify from the given data so that it will help us to understand and finalize and make our strategies set that more bookings will happen in the month of December. Whatever, I've taken December as an example. Now, how it will be done? So it will be done based on the Euclidean distance that is calculated between the points. So let me give you an example that you have these points. Okay, so you can see that these points are very close to each other with some x value, not much. Okay, so you can see that these points are also equal. So these points are also equal. So these points are also equal. When you have a new point, let's say example, this point. Now, this point is nearer to which classification? This classification. Of course, it is very nearer to this classification. Like this, when you have a new data point, you just need to understand to which classification it is nearer. So you will be having different classes, different categories, and need to understand to which category it is very close to each other. So that is a simple KNN that is giving us to understand the data, what is all about. So the measure of similarity between the two instances. I'll give you one example, just generalized example. So carrot, apple, radish, mango, beetroot, orange, and brinjal, papaya. So if I give this as vegetables and fruits, you already know that it has been segregated based on some parameters, based on the content that they have, and you already done. Now, if I give some content, let's say example, for which when you have these contents, it will be vegetable. When you have these contents, it will be fruit. So you have segregated. So you know there are two outputs that will be either vegetables or fruits. You already know this. This is the output. But based on the parameters, it says vegetable. Based on the parameters, it says fruits. So when I have this particular parameter in future, I just need to tell whether it belongs to vegetables or fruits. So that is my future helping. So instead of me understanding what it is, based on that particular parameters or values, we'll be able to understand whether it is vegetable or fruit. So that is provided by KNN, which we also referred to be as lazy learning method. So it takes time when you increase the data set because it needs to calculate the distance between each and every coordinates and then try to make a features. So Euclidean distance formula is P1 Q1, P2 Q2 whole square, Pn Qn. So I'll just diagrammatically show you how it looks. So whenever you have a k nearest neighbor, the k value is also decided manually. So you just need to understand how many data points you need to know. So if I say k points as 10, so when you have a new point, it will consider 10 points which is nearer to them. Like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, one more. 10. So it will take only those points. And earlier, we already decided whether the points are pink color or blue color. Okay. So now you can see that the newly created point, the newly arrived point is in pink color because it is closer to more pink color than more pink color. You can see that 3, 6, 8, almost not 8. Okay. So almost 5 pink colors you have, and you have almost 3 blue colors. So when I say 5 and 3, majority you will be having pink colors. Hence, the particular value that you got as a newly arrived will be your pink color. So that is chosen by making a distance. Making a distance. You can see that it is covering all the 1, 2, 3, 4, 5. So you have only 3 out of 8 nearest neighbor. You have 5 which is closer to this point. Hence, majority wins pink color. So hence, this also belongs to pink color. That is what KNN is all about. KNN is telling. So hope you're understanding. Okay. So now we'll try to understand how it works. So whenever we get a data science problem, first we need to understand the business understanding. So now what is the problem statement? Here the problem statement is hotel strategy to predict booking. So what does it predict? It predicts the booking in which month the booking is high. So it is going to predict the booking based on the different criteria. Let it be market segment, let it be different month. When you have a different profit, you can analyze by taking different parameters, but you need to predict and make your strategies based on the bookings. Okay. Now, data understanding. So collect the data. Let it be from primary source or secondary source. Next, after understanding business understanding and data understanding, try to explore the data and process it. Processing the data, that is cleaning. It can be with respect to graphical representation, or it can be by doing some simulations. Like if you have any missing values, if you have any duplications, if you have any noise in the data. So those all does not give you good accuracy. So why we are doing this as a major portion? Because the data in itself is a gold for our machine learning machine learning algorithm. So it should be giving you good accuracy. So for that, you just need to prepare it. So when you get a good quality of vegetables, your food which you prepared will also be tasty. That is the simple example that we can understand. So we need to prepare our data. We need to data pre-process. So what is the next process? Next step? Next step is model selection. This is, what is this we are studying? This is all about CRISP MLQ, which is very much required for all the problem statement. Whenever you work, you just need to follow the same procedure. First, understand what is the business telling about with their objectives and constraints. Then collect the data, try to understand the data by doing pre-processing and exploratory data analysis, clean the data and be ready. Now you just need to select the model and then do the model selection. After model selection, you just need to estimate that whether it is correct or wrong. So you do require model evaluation by passing the testing data. So once model is selected is correct model and your model is also evaluated at a good accuracy level, then you can deploy that and then you proceed with maintenance and monitoring. So this is the usual step that we follow. So we understood what is the business understanding, data understanding, we'll do EDA and then we'll do selection. So under model selection, today we have selected KNN for our data. And we'll try to understand, estimate how it is evaluated by predicting. First, we'll train the model with the help of trained data, and then we'll test that, evaluate that model using test data. So now, first, what is the first step? We need appropriate packages for KNN. You do require sklearn.neighbors. Under that, you have kneighbors classifier. So this package will perform your KNN algorithm, selecting all the required data and then finding the distance and then telling to which category it belongs to. Okay. So before that, we just need to understand the data and then pre-process it. So we have our data. The data is all about hotelbooking.csv, and we have all these features and the data. And we describe the data. Whenever you run this particular method, we know that it only performs on the column which is having numerical value, because it is going to give what is the mean value, what is the standard deviation, what is the maximum value, what is the minimum value. It gives you count. Okay, so all these values will be given by describe. Now we need information of that particular data, and which in turn try to understand the type of the features. You know, in a tabular column, the first row will be your column heading. Column heading will give you the meaning of that particular column. So that particular column head should be of certain type. The heading should be of certain type. It should be of integer. It can be of string. It can be of numerical values, that is floating point. It can be of object, combination of all these three. And it can be of Boolean. So like this, different types can be having for the column heading. So that we can get it from this method, that is .info. So which will be giving you whether you have any null values and how many you have null values, that will be also given. So you can see that whenever I run this particular line, I'll be getting all the features. So these are all the columns. Okay. And what is the count of that? You have 1,19,390 rows. And how many columns are there? You have 36 columns. Okay. So you can see that data columns are 36 and the range index is 1,19,390. Okay. So this is the information that we have: object, integer, float, object, integer. Like this, you will be having different categories and it will give you the information. And when you are getting the information, you can see that everywhere you are getting not null. That means it is not empty. It is not empty. But whereas in company, it is showing 6,797 empty cell. So here we are getting count and it is giving you empty. Okay. So for that, what you'll do, you'll calculate the data in the data frame, you calculate the null values for that particular column, and for overall null, whatever you have, null value percentage, you will calculate. Let's say example, you have a column. In this, there are 10 rows. Okay. So overall 10 rows, you have one column. So it is 0.1%. So this we calculate in that particular column. What is the percentage of empty? So out of 1,19,390, if I have 19,390, then it will be somewhere around 1% or 10%. So like this, you just need to estimate what percentage of value that you have empty in the particular column. So from that, you can understand the country has 488.4% contribution. That is, it is empty overall. And here also you can just get 16,340, which is contributing 34%. And the company is also having a empty value, that is 1,12,593, which is having 94% of empty value. So like that, it will give you. So whenever you say that you have these null values, you just need to judge. Let's say example, company does not have any value here. Most of the cells are empty. But when you are doing some calculations or analyzing, the company name is not required. Not at all required. It is not at all required. Hence, it does not play any important role when you are applying either model or doing some calculations. So you can just neglect and ignore you can drop that particular column if you don't need, and if it is useless. Sometimes ID, email ID, contact number, and alternative number, and ID proof, serial number. So all these columns are not required. So you can drop that columns and you can consider only the columns which is required. So that is the probability that we can make use, or else even if you do require those columns and you don't need any of those values, you can just simply make that empty as 0, so that it looks like it does not have any empty cell. So these are the columns that is having some percentage of values with a empty. So you just need to filter from the data, saying that if the children column, this is a column, and sometimes adults column and babies. When you are going with friends, when you want to fill this particular columns, you will fill only adults. You'll make it as 0 for babies and children, because you are going friends. Nobody there children and no babies are there. So these are all also not counted, but you can filter and ignore. You can filter and ignore. So I'm filtering if children is 0, adults is 0, babies is 0, you put it in filter. One more variable. You just separate that particular columns which is having these kind of criteria and make this whole thing as one filter. So that I have made it as df of filter. Now proceeding further, I'm talking about data. Okay, so apart from that particular columns, let's say example, children, babies, adults, all these are under filter. So I need to consider only from those, except these columns, I need to consider the remaining. So when I say true, I can say not true. So this can also be told as false. So that is what we are doing. Apart from true, what is that? False. I can take not true. So that's the reason I'm taking here not filter the rest of the columns. So here, after considering the rest of the columns, you have exploratory analysis. You explore the data based on country-wise guess. You need to understand from where and all the people have blocked their hotels or restaurant. So these are the numbers and their countries. So with the help of graphical representation, we represent that particular data, and from this we can understand from this area they have blocked more number. From Portugal, from Europe, they have blocked more. So we can understand from the graphical representation that from where the number of guests are more. So when you proceed further, we also understand how many people they are cancelling the request, cancelling the room. So we have a cancellation room with respect to resort and with respect to hotel. So you can see that after getting the box plot for each and every values, where you will be getting reserved room for a type, reserved room type, whether it is A, B, C, D, E, F, G, whatever. So, and average daily rate. So you have these categories. So these are all outliers. So these are all outliers, which is away from, apart from the value range. Okay, these are all outliers. So it may impact the accuracy also. Okay, so we just need to concentrate on that with this graphical representation. Now we just need to understand whether the resort has more number of cancellation or city hotel has more number of cancellations. So where their arriving. So for resort hotel, both arrival date month will be given. Based on that, they'll book the room. So arrival date of month, date month, and ADR that has been given. April has this, August has this, December has this, February has this, January. So based on the month, it has been calculated. Now, when you are calculating the average rate, again with respect to city hotel, and it is grouped by arrival date month and ADR as taken as mean value. So average daily rating that will be considered in the month of April for city hotel. So earlier this is for resort hotel. So now it is city hotel. So we need to compare both. We need to compare both by merging city hotel on arrival date month, and the columns will be month, price for resort, price for city hotel. You can see these three will be your new columns for final hotel. So you have merged, that's it. Next, moving further, you need to understand the data month with respect to price for resort and city hotel. You can draw graphical representation where blue color indicates it is a price for resort and price for city. So city, it will not be crossing 120. So it is highest in the month of May. So we can easily understand here. And in the month of August, it will be very high with respect to resort. So from the graph, we can easily understand. Okay, so some changes have done. So it is changing. Now, this is for resort guest. That is for hotel guest. Now, this is for city guest. Combining the guest together, how many of them are going for hotel? How many of them are booking resort? That is also extracted. So finally, you have these two, and the same thing I have made it as graph. So it is just a replication of understanding the resort and hotel with the number of guests that they are arriving. So after that, we have a filter is cancelled equal to 0, and the rest will be your data. Now, so total nights that they have stayed in the weekend and the weeknights. So that is also calculated here to understand. So it is an optional. So you can just do an optional that whenever you have a time, you can just go with the total nights hotel and get the count of that. So you can see that the total nights they have stayed is all these days, and they have number of stays. Okay, so these can be graphically represented. So when you get the heat map for all the columns, you'll be getting that. And you can cross verify the strong correlation between the features. So you have strongly correlated between previous cancellation and booking changes, required car parking, and lead time, total special request. So all these are the categories that is giving importance. You can see that it is having more importance, no more percentage than this. Stays in the weekends, children, arrival date time, babies, ADR, agent, all doesn't matter. So they need car parking, booking changes will be done, previous cancellations are also done, and the total special request will be done. So lead time will be your 30%. So with this information, some of the information which we don't require, which is having less probability, so we are going to remove that, drop that with the help of drop method, dot drop useless. And then we get the exact value. So in this particular data, we have categorical data. So these categorical data will be encoded and made it as numerical values. So the variables which are in alphabetical or string cannot be sent into the model because the model has some calculation in the numbers with respect to numbers representation. Hence, we need to convert that as a numerical format. The hotel, arrival date, month, meal, market segment, distribution channel, all these have categories. So we need to change that particularly into categories with the values. So you can see that this particular column, hotel, arrival date, month, meal, market segment, distribution channel, reserved room type, deposit type. So it is having categories. So we just need to convert that to make as a numerical value, and we can drop some of the columns that is not required. So that we have done here to understand. See here, you can see that it is going to print the categories. Under hotel, you have two categories. Under meal, you have these categories. Under market segments, you have these: distribution, deposit time, year, month, day. So you can see day also there, month is also there, year is also there. So these are the categories which we made changes. After dropping some of the columns, you get all these values. So which is having variance with respect to the columns. And the number of lead time, we are doing normalization or transformation, we can say, because we have big numbers. So when you do logarithmic value, it will be easy for us to calculate and the computation cost will be easy. So it will be 2.4 and it will be 0 to 1, 0 to 10. So like this, and you need to fill the values that you are not getting with the any numbers. That is what we call it as fill NA. So next we'll take the values. That is categorical data, numerical data. And whatever is cancelled is going to be output. So then you have the X shape and Y shape. You need to split the data as test data and train data. So once you split the data, you apply the same to the K nearest neighbor. First, you need to do with the train data. So when your model has trained, it has been fitted with train data. Next, you need to predict the data with the X test value. So KNN is your exact model, which you got trained from X train and Y train, which is having a accuracy of 90%. When you are testing for test data, your accuracy score will be calculated with the help of confusion matrix. So the confusion matrix is giving you 92% result. You can see F1 score. So hence, whatever you have the data with respect to the hotel management is 92% accurate. So you can just easily understand whenever there is a new feature, the new arrival to the data, you can easily judge whether it is going to have a cancellation or not cancellation based on different features. So that is what KNN is all about telling. So it is identifying whether it is going to have cancellation or not, in which month it can be cancellation or it can be in which. So like this, you will be having different analyzing strategies also can be made with the help of machine learning models. So here the classification model, that is k-means, KNN, it is helping us to understand the data and helpful for predicting the bookings. So when you calculate the test data and train data, which is having almost equal accuracy, then you say that your model is working fine with the data. So the data does not have any such variations. So you can easily use for a prediction and make your own strategies. So this is all about with respect to KNN on hotel industry or hospitality data analytics. So if you have any queries with respect to this, you can just ask. So there is one question which is with respect to heat map. Okay, so I'll just show you that heat map. Yeah, you can see here the heat map. So why we are getting one here in all the diagonals? Because it is with respect to the same column, so which is having strong correlation. So it is going to check which is having strongly correlated. So whenever you find some darker place, here you can see whenever it is moving towards these zone, these lighter zone, like 1 is your maximum, 0 is your least. So whenever you have a lighter note, you can see that this is 29% and this is somewhere 49%. And you can see some of them are 33%, which is that you'll be having children with ADR. So you can easily understand which two columns are strongly correlated. So with this, you can easily understand which two columns are strongly correlated. When you change something, you will be getting affected to the data or model, which does not help you for taking some decision or making predictions. So hence, from the heat map, you can easily understand the data, whether it is strongly correlated or not strongly correlated, and what is the relationship between them. So you can easily understand. So that is help of heat map. Okay. So this is all about for today. So we'll see one more model, machine learning model, in the next session. Thank you all. Have a nice time. So please do subscribe for the channel and please do follow our LinkedIn profile as well as Facebook profile so that you'll get updates on the new topics, webinars that will be conducted, and all the works, tasks which will be upcoming in further days will be updated in the profile. So please follow that and get updated and make use of that. Thank you all. We'll see you tomorrow in the next session.